Hi guys, we're going to go ahead and start skill 4, identifying functions. Go ahead and get out your notes and start taking notes. The page numbers are on the bottom. If you have questions on that slide, you can ask your teacher. So first let's start with the definition of a function. The definition of a function is when every input has exactly one output. This means we cannot repeat inputs, but we can repeat outputs. So when we look and decide on these, if the inputs repeat, or if these are functions, we're going to look and see if the inputs repeat. Inputs is the same as domain, so I'm seeing do any of these inputs repeat? I would say they don't, so I'm going to say yes, it's a function. Here I'm looking, do any of the inputs repeat? Go ahead, answer that on your own. So you're looking, do any of the inputs repeat? You should have gotten yes, it's a function. Here I'm looking, do any of the inputs repeat? Those do repeat, so it's not a function. Look at this one, do any of the inputs repeat? Answer on your own. So this is also not a function. If we look at these two graphs in relation 1 and relation 2, I'm seeing if there's multiple arrows, so I'm looking, do any of my inputs repeat? They do not, so yes, it's a function. It's kind of hard to tell. Here, do any of my inputs repeats? I see that my y goes to two different outputs, so my y repeats. So this is not a function. Do my inputs repeat here? No, so it is a function. Do my inputs repeat here? No, so it is a function. Okay, next we're going to talk about the vertical line test. Is how you decide if something is a function. If a vertical line hits the graph more than once, it is yes, a function. If a vertical line hits the graph, more than once, it is not a function. If a vertical line hits the graph only once, it is yes, a function. So on all these, remember, vertical lines go up and down. So if I draw a vertical line here, it hits here and here. So this is not a function. If I draw a vertical line here, it hits it twice, so it's also not a function. If I draw a vertical line here at each of these, it doesn't hit twice, so it hits only once, so it's yes, a function. I want you guys to try 4 on your own. So if you did 4, it hits it twice, so it's not. Graph 5 is a little trickier, but however, if you guys remember, if it's a closed circle, that means there's a value there. If there's an open circle, that means there's not a value there. So technically, there is no value. It only has a value here, so it is still yes, a function. This is also yes, a function. The next thing we're going to talk about that we've kind of already been talking about is this idea of domain and range. Our domain is inputs or x values. Sorry, that looks bad. Our range is outputs. We usually write them in set notation. So we put these brackets, then we put commas. So we'll see this more in the next slide. So let's go ahead and identify our domain and range using set notation. So I'd have domain. I'm going to do domain as my inputs. So it's going to be 8, 8, 2. Let's do my range as my output, and I'll do that in green. M, P, and Q. So we have owners of a recreational area are filling a pond with water. Let W be the total amount of water in the pond. T is the number of minutes that water is added. Suppose that W equals 15T plus 40, where W is a function of T during the next 90 minutes. Identify the domain and range. Of the function. So we have an input. T is our input. And W is going to be our output. So our input is domain. So my input is time. So it's the amount of time. And it says I can only add 90 minutes. So it can be 0 to 90. My output is W, or the amount of water in the pond. And we want to find W at 0 minutes. Because if we find the value of W at 0 minutes and W looks like Y if I don't write it without the W. And then this way I know all the values that Y could be, or all the different amount of water that's in there. So let's go ahead and put when when T equals 0. So at the beginning, W will be 400. This is basically when T equals 90. So W can equal anywhere between 400 to 1,750 liters. And that's whenever we started from 0 minutes to 90 minutes. Next, I'm going to talk about this idea of function notation. So when we see this f of x equals something, f is just the name of the function. This tells us our input, and this tells us how we found our output, or the equation. So if we see an example of this, let's do f of 3 first. It's asking us to use the f function, and everywhere we see an x, we put a 3. So if it's helpful, we're using the f of x function, and then it's asking us everywhere we see an x to put a 3. And then I can just solve this. So f of 3 equals negative 21. The same is true. It wants g of 4, so I'm going to start with my g function. And everywhere I see an x, I'm going to put a 4. So we know g of 4 is negative 11. Okay, this is asking us to put in h of negative 5, h of 0, h of 2, h of 4, h of 5. I'm going to go ahead and get us started. So this spot's basically asking for h of -5, h of 0, h of 4. I'm going to go ahead and find h of -5 for us. Everywhere I see a -5, I'm going to put -5 where h is. So that'd be 20. Go ahead and pause and do the rest on your own. Okay, this is what we should have gotten for this one. Sometimes these come in the forms of word problems. A plant is already 9.5 meters tall. That's where it got this 9.5, and it's growing 7 centimeters every month. The plant's height in meters, so they converted centimeters to meters. After x months is given by the following function. What is the plant's height after 15 months? In other words, it wants h of 15. So I have my h function. Everywhere I see an x, I'm going to put a 15. And then I can solve it. So, and this is going to be meters. After 15 months. Okay, last problem. Sometimes we can put in things that are not numbers. So this is asking us to put in a 3a. So everywhere I see an x, I'm going to put in a 3a. And then I get this.